continued to focus on the key problem, which was getting the weight of the whole system down. They did this in two ways. One was the divided shield concept, where they were continually trying different twigs and different materials in order to improve the efficiency of that. The second way they looked at was decreasing the reactor size. The only problem with decreasing reactor size is that in order to keep the performance the same, you have to increase the temperature so that you end up with the same amount of thrust produced by the smaller engine.
O progresso em todas as frentes, motor, blindagem, energia do reator, era lento. E agora, o bombardeiro atômico tinha um rival. A Marinha Americana, sempre com ciúme da Força Aérea, tinha começado seu próprio projeto de um avião movido a energia nuclear.
What the Navy did is it went back to the idea of the original MIT team of the 1940s who talked about flying boats. So the Navy decided an atomic-powered flying boat would be a very good idea.
It would be peculiar if nobody in the Navy thought about using a nuclear reactor for a flying boat, as long as the Air Force is thinking about it for something else.
A Marinha queria uma versão movida a energia nuclear do Martin C. Master, o primeiro hidroavião movido a jato do mundo. Para vencer seu rival da Força Aérea, a Marinha Americana buscou apoio inglês. A Inglaterra tinha um hidroavião gigante capaz de carregar o peso de um reator nuclear, o Princess da Saunders Roe.
The US Navy Bureau asked Saunders Roe to provide a brochure study of putting a nuclear power unit into the Princess flatboat for use by the US Navy. And I seem to remember a sum of $50,000 being paid to us to do the work, and which we did, and delivered not only a brochure but a model of the aircraft.
Dick Stratton foi encarregado dos testes de voo do Princess.
The main thing was to install a nuclear reactor in the upper deck, which would feed hot gases to the inboard power plants. And the aircraft would take off on turbine fuel, and when it was up and away, they would then switch off the turbines and go over to the nuclear-powered turbines on the big inboard engines. And of course it would stay up for as long as you wanted it to stay up.
Mas a Marinha Americana logo abandonou os hidroaviões movidos a energia nuclear em favor de outro sistema bélico nuclear, o submarino atômico.
The great advantage of the nuclear-powered sub was that you could use the heavy lead shielding in the submarine. Weight was not a problem, and therefore you could also carry a much bigger reactor, and you could shield the crews of the nuclear submarine so it, like the proposed nuclear bomber, could sit undetected underwater off the coast of the United States even to fire its missiles, or off the coast of Russia to fire shorter range missiles, or indeed almost anywhere in the world to provide that independent and safe nuclear deterrent.
Os dois projetos, o hidroavião movido a energia nuclear da Força Aérea e os submarinos atômicos da Marinha, tornaram-se rivais mortais.
One of the inspirations the Air Force had for building a nuclear airplane was that the Navy had a nuclear submarine, and they weren't about to be left out in this high-tech propulsion area.
A realidade era que o programa do bombardeiro atômico estava em crise.
In 1956, there was some good news and some bad news for the atomic-powered project. General Electric Company at last managed to get a nuclear-powered jet engine prototype working. But the bad side was that the thrust produced was nowhere near enough to lift the whole system off the ground.
A Força Aérea e a General Electric passaram a buscar mais dinheiro para o programa do bombardeiro atômico. Mas elas se defrontariam com um obstáculo inesperado, o presidente Dwight D. Eisenhower.
President Eisenhower, as a military man, was very suspicious of the military-industrial complex, and always suspected that these kind of companies were pushing projects too far and too fast just in order to gain big contracts. His Deputy Defense Secretary then ordered a stop to the X6 and WS-125 programs in the view that they were just far too ambitious. And I think that was a realistic assessment. So he ordered those programs stopped and ordered the agency to concentrate on trying to get the engine right.
Como resultado, o reator voador NB-36 fez seu último voo no dia 28 de março de 1957. foi aposentado em Fort Worth no final de 1957. Foi desmanchado vários meses mais tarde e suas partes radioativas foram queimadas. Parecia que o projeto de um avião nuclear havia sido enterrado. Mas no dia 1º de dezembro de 1958, a Aviation Week, a revista de defesa de maior autoridade da América, divulgou uma história impressionante. A União Soviética tinha colocado em voo um bombardeiro atômico.
They had a picture of it. It was just an artist's conception, but it was a nuclear-propelled airplane.
A 4-engine delta-wing nuclear-powered bomber was reported to be flying from the Moscow area, and this has been independently reported by other sources. The interesting thing about this was that the article claimed that this was not just a test bed for flying a nuclear reactor around in, but it was actually a nuclear-powered bomber, and this really put the Americans on their toes.
A América já sabia que os soviéticos tinham colocado em órbita o primeiro satélite, o Sputnik. Parecia que os russos estavam à frente tecnologicamente.
Well, Sputnik in America was a negative surprise, because here is a high-tech accomplishment by these backward communist Russians. And so the only way that could happen is, I'm quoting now, is that something is wrong. Something's wrong in America that has to be fixed. And the people who cause this to be wrong are the people like Eisenhower, who, are not sufficiently imaginative about when they deal with these great ideas, and it's got to be fixed. So there was tremendous pressure on the government and within the government to just do project after project after project, all in response to Sputnik. I mean, we were going to respond to Sputnik in 100 ways.
Uma das maneiras era ressuscitar o projeto do avião nuclear. A Força Aérea e políticos simpatizantes lançaram uma campanha para restabelecer o WS-125.
There really were passions connected to this nuclear airplane. And one of them was a Democrat from a labor district in Pennsylvania named Dan Flood. And he had this article in Aviation Week with this picture. You guys are asleep at the switch again,
Representative Melvin Price, chairman of the Joint Congressional Atomic Energy Subcommittee, actually declared that the Russians were now 3 to 5 years ahead of the Americans in terms of nuclear aircraft propulsion, and declared that the Americans ought to really do something and step up their efforts to get even.
I remember one classified meeting we had with one of the military appropriations committees of the House of Representatives about this Aviation Week article. Why aren't you guys doing so? Don't you understand how important this is? But I knew enough about the level of Soviet technology to not take it seriously. I mean, I knew how hard it was to do. And I didn't think they could, I didn't think we could do it, and I certainly didn't think they could.
De fato, a Rússia trabalhara em segredo em torno de um avião movido a energia nuclear durante muitos anos.
There was one really wild project they had in the early 50s for a flying boat that weighed 1,000 tons. But the real emphasis of the Soviet military was to keep pace with the Americans and build their own version of a nuclear-powered bomb.
Os soviéticos já tinham um bombardeiro estratégico de longo alcance. No Ocidente, ele era conhecido sob o codinome da OTAN, o Urso. Mas o Urso era lento demais para penetrar as defesas de mísseis e de caças da América. Agora, parecia que a Rússia estava desenvolvendo uma alternativa nuclear. Era chamado de M-50. Seu codinome na OTAN era Bounder. Mas como os soviéticos tinham ultrapassado a América em aviões movidos a energia nuclear?
The Soviet researchers into nuclear-powered aircraft paralleled the American ones. They had the same problems to confront. The weight of the reactor, the shielding, and they came up with much the same kind of solutions. The Russians went down the distributed shielding route as well. Curiously, the Soviet figures for the weight and size of the reactor they wanted to fly with is very similar to what the Americans came up with, about 80 tons.
Estamos apresentando Aviões que Nunca Voaram. As notícias sobre o êxito do avião atômico soviético, aliado ao lançamento do Sputnik, mudaram a política americana.
The AEC, the Defense Department, or several Defense Department officials, and the Air Force then threw their weight behind an effort to get the program back up to the prestige level and the amount of input that it had before, and tried to urge the president to back it so that the Americans could have a plane flying by the early 60s.
O presidente Eisenhower elevou o orçamento para o projeto do avião atômico da América, mas continuou desconfiado e colocou o programa sob uma administração em que pudesse confiar.
By that time, I had already developed very substantial doubts about its practicality. The goal is a reasonable goal. I mean, an airplane with an indefinite flight time. But the practicality, and I could summarize it in three different areas, all of which are closely related. One is that airplanes are subject to crashing. The idea of flying around with a reactor, which sadly might crash anywhere, is just not something which could be made acceptable. The second point is that especially on the direct drive, or the direct reactor, direct heat, it was inevitable that it would constantly be spewing radioactivity out the tail. And the other one was the pilots. I mean, the question of shielding the pilots was a serious one.
Herb York was a good scientist who knew that they hadn't cracked the four major problems. They still hadn't built an engine that was powerful enough to get the whole